today we're going to simplify the following expressions. These problems are about simplifying exponents and such. And this is part 2 of a series of videos on simplifying expressions. Part 1 was dealing with simplifying expressions that were a little easier to work with, more basic, and using some of the more basic rules. These expressions are a little more complicated, dealing with the fact that one, you have to use more than one rule to simplify, and or you have options here that you can use many options to simplify it. That's actually kind of hard when you're dealing with a math problem, because sometimes you want to, just the straight answer or just one way to do this, but sometimes there's more than one way. So we'll take a look at that. Now, before I get started on these problems, let's go over the rules of exponents here. Number 1, a to the b times a to the c equals a to the b plus c. A to the b, number 2 says a to the b divided by a to the c equals a to the b minus c. Number 3 says a to the b to the c equals a to the b times c. So these are I would say the first 3 rules, which are the most basic ones here for rules of exponents. And that's what I dealt with in the last video, in that first video on the series of exponents. Now, rules 4, 5, and 6 are newer rules here. And rule number 4 says if you have a product of 2 things, actually it could be 3, but we typically just write it out, or 3 or 4 or 5, it's the product of a bunch of things, and all of those are raised to an exponent. It's equal to each part individually raised to the exponent multiplied. So a times b all raised to the c power is equal to a to the c times b to the c. But again, it could be more things than just 2. It could be like a, b, and d all raised to the c, and then be a to the c, b to the c, d to the c. And then we have the quotient raised to an exponent. Say we have a divided by b to the c equals a to the c divided by b to the c. And then last but not least, a to the 0 is equal to 1 with a not equaling 0. Okay, and we'll use that for our last example. All right, so let me get started with number a here. So with a, you have a couple options to work with. The first thing, if you notice, is, well, the first thing I'd like for us to notice, is that you have an x to the 7th, x to the minus 11th, y to the minus 2, and a y to the 3rd. And what I'm getting at with the inside is that you can actually subtract some of the exponents. Okay, so you can do that. You can say to yourself, x to the 7th minus negative 11 times y to the minus 2 minus 3, all raised to the 2nd power. That's legit. Or you could also use rule number 5, which says that if you have x to the 7th, y to the minus 2 over x to the minus 11, y to the 3rd to the 2nd, it's equal to x to the 7th, y to the minus 2 to the 2nd power, all over x to the minus 11th, y to the 3rd to the 2nd power. So both options are legit. You can go with both. Okay, which one you'd want to use, that's up to you. Personally, I prefer the first option here, and that's what I'm going to work with today. But if you're going to go with the second option, I'll get to a little bit into that in a couple minutes, because I definitely want to go over that option and tell you how that would work out. And so I'm going to just erase, well, let's say move it for a second here. And then you have, so what we're going to do is we're going to simplify this a little more. 7 minus negative 11 becomes 7 plus 11, or x to the 18th. Negative 2 minus 3 is a minus 5, all to the 2nd power. So we simplify that, and then we're going to go ahead and use rule number 4 here, because I have a product of 2 things raised to an exponent, and what that rule says is that you take your 2 things that you have, or 3 or whatever number of expressions you have, and you will go ahead and multiply the power. So x to the 36, y to the minus 10, and then last but not least, this is going to be x to the 36 over y to the 10. because I want to write out every negative exponent with a positive, and with a negative exponent you put it under 1. If you went with the other route here, you would have x to the 14th y to the negative 4 divided by x to the minus 22, and then you would have y to the 6. And then you would have to simplify this by subtracting the exponents. 14 minus negative 22, y to the negative 4 minus 6. So you would have x to the 14 plus 22, which is 36. This is y to the negative 10, and same exact answer. Okay, so you have options. I just wanted to let you know you can, several ways of doing this. No one way is correct. As long as you follow the rules, you're good. All right, so we have 2x to the 9th, y to the 3rd to the 3rd, 4x times 4x to the 5th, y to the negative 3 to the negative 2. So we're going to be using, back to our rules here, we're going to be using rule number 4 to start off with on both these two expressions. Okay. So let's go back there. All right, so I'm going to use that rule which says, if you have a product of expressions raised to a power, you take each term and raise it to the power. So 2 to the 3rd, x to the 9th to the 3rd, y to the 3rd to the 3rd, and likewise I have 4 to the minus 2, x to the 5 to the minus 2, and then you have y to the minus 3 to the negative 2. Sorry, my writing is as bad as it is, it's getting worse. Like that. And I would have, let's see, I'm going to simplify this a bit now. 2 to the, in fact, let me get rid of this. It's not necessary. 2 to the 3rd is 8. X to the 27th. So I'm using more rules of exponents here and here. With the number 2 to the 3rd is just 2 times 2 times 2, which is 8. Again, I'm using rules of exponents. I'm using the 3rd rule. Y to the 9th, 4 to the minus 2. I'm going to rewrite that as 1 over 4 squared. X to the minus 10, y to the 6. And 4 squared is 16. So we'll make a note of that. And let's see what we have. I'm going to put the numbers together. We're allowed, basically, when you have a product of a bunch of expressions, you're allowed to kind of write them in the order that you please. So all I'm saying is you can move things around and put them, for example, I can put the x's together and I can put the y's together. Okay. So 16, 8 over 16, I'm sorry. And then you have as follows. You have 8 to the 8 16ths, x to the 27, x to the minus 10, y to the 9th, y to the 6. And 27 minus 10 is 17. Y to the 9th times y to the 6 is y to the 15th. And then 8 over 6 is 16, is a half. So that is what we would have left. If you prefer to write this out, you can put this as a single fraction, as such. And that is your answer for that. All right, so finally for our last problem, 3 to the 2nd, which is 9, x to the 0, which is 1, times 5, plus 4 to the 3rd, 64. So you have 9 plus 5 plus 64, so it's 14 plus 64, which is going to give you 78. So very important here, let me stress that pretty much anything to the 0, as long as it's not 0, is equal to 1. So yeah, that's why we have x to the 0 becomes 1 times 5, and there you go. Okay, so these were a little more complicated problems in the great scheme of things compared to like the basics, I guess you can say, with properties, with learning the basic rules of exponents. So thank you for your time, and I hope this helps.